Hello, everyone, and welcome to Coderific. If you've been learning AI recently, you've probably noticed one term showing up everywhere: AI agents. They are being used to build chatbots, coding assistants, research assistants, and all kinds of intelligent applications. But if you are just getting started, it's easy to wonder what actually makes an application agentic? What changes compared to the Python programs I've been writing all along? The best way to answer that question is by building something we already understand, and that is a simple and very basic calculator. In this video, we will learn to build it twice. First, we will build it using traditional procedural programming. Then we will rebuild the same very calculator as an AI agent. The functionality won't change. It will still add, subtract, multiply, and divide numbers. The interesting part is how each application decides what to do next. As we build both versions together, we will go through the code from start to finish. We will understand why each library is imported, how the user's request flows through the application, how the calculation is performed, how we create the user interface, and how everything comes together into a working application. By the end of this video, my goal is that AI agents no longer feel like a mysterious new buzzword. Instead, you will see them for what they really are, which is another way of designing software. More importantly, you will know when a straightforward Python program is exactly what you need and when introducing an AI agent genuinely makes sense. So, let's start with the procedural version of our calculator. This notebook shows our first application, which is a Python calculator using conventional procedural language. Here, the user will provide three structured inputs: first and second number, and the required operation to be done on these two numbers. The program then follows explicit Python logic to produce the results. We begin by importing Gradio. This library we use to create a browser-based interface around Python functions. It will be responsible for the text, number, and drop-down components, the buttons, and the local web server. Format number is a helper function which improves the representation of the answer just to increase the readability of the output. This is the main function of the procedural application. As we can see here, it received three values collected by the Gradio interface. So next, we have a clear calculator function, which resets the four interface components created by Gradio. Next, with gr.blocks, we create Gradio application. gr.blocks creates the application container, and the variable app represents the complete Gradio interface. Let's run the cells one by one. Starts the application of Radio server. At this point, the procedural calculator is complete and its behavior is easy to test. So if I change the first number to 2, then select the operation multiply 3, it should give me the answer in a readable format as we have specified in our deterministic functions. Now at this point, the procedural calculator is complete. Let's close the server. All right, let's compare it with the AI agent calculator. In this version, addition is still addition, division is still division, and rest of the operations are still as they are. The main change is how the application determines which operation the user requested. So instead of requiring a drop-down, the application accepts natural language input such as add 14 and 9 or subtract 5 from 20. The language model must interpret the wording, choose a suitable tool, and construct its arguments. The application then executes the selected Python function. Large language model is very important here. It is the one that handles language interpretation and the selection of right tool. Let's start with the imports. The agentic application needs substantially more infrastructure. These imports are standard library modules, and here we use Qwen 2.5 model that is instruction tuned and 3 billion parameter. Here the model learns locally. The application does not send the calculation to OpenAI, Anthropic, or any other proprietary model API. It's important to remember that not every LLM is trained or configured to generate tool calls. A normal text generation model may only return prose. It may not understand tool schemas or produce valid tool names and arguments. Therefore, when building this type of application, we must select a model with suitable instruction following and tool use behavior, or add a reliable structured output layer around it. In this example, the code also handles a practical compatibility issue. Here we load the model using the model name, selected data type, device map, keeping it auto, and keeping true value for this parameter helps reduce peak CPU memory usage during loading. Next, we define mathematical operations into the format of tools. This tool decorator exposes the function name, description, and argument schema to the model and LangGraph, and the function itself performs ordinary Python addition. Once we are done creating the operations as tools, next we create a tool list. This list basically defines the complete action space available to that agent. Here in this application, the model does not invent new operation or tool. It can only request one of these registered tools using tool decorator. Next line is very important, where we are binding these tools to the model using bind underscore tools. This function provides the tool definitions to the chat model we created above. In the next step, we create system prompt. In this system prompt, we define the model's operating instructions. And these instructions tell the model to select exactly one calculator tool for every valid arithmetic request. It also tells the model to provide numeric values for A and B and avoid calculating the answer itself and use the tool result. And providing the examples of the right behavior help reduce the ambiguity for that model. Then we have assistant node. This is the model node in the LangGraph. Next, we are building the LangGraph. Here we are creating a graph whose shared state is a list of messages. Then we add the assistant node first. Then we add pre-built tool execution node. This will read the structured tool call from the latest AI message, finds the corresponding Python tool, and executes it with the supplied arguments. The graph begins at the assistant node. After the assistant runs, conditional routing is applied. Tool condition examines the assistant message. When it contains a tool call, execution moves to the tools node. When it does not contain a tool call, the graph can finish. In these lines, we are telling basically after a tool executes, control should be returned to the assistant. Then, with the help of gart or blocks, we create the main application container. Let me run all of these cells from beginning. Libraries are loaded. Then we load the model. Model has loaded successfully. Then run the rest of the cells and then launch the application. This is the final application. Let's pick up one of these prompts and paste it here. Click the calculate. It is taking time. So this application took a few seconds, more than 50 seconds to respond. And I'm running this application locally on 32 GB of memory, locally on a computer with 32 GB memory. Here you can see the output and the long trace of LangGraph execution. Once we have observed the output, let's close this server. One thing you may have noticed is that in this video, I didn't spend much time discussing the formal definitions or theory behind AI agents. That was intentional. My goal for this video was to keep the focus on the practical differences by building the same application in two different ways. I believe that's one of the easiest way to understand how agentic applications actually work without getting overwhelmed by terminology. But if you want me to create a separate video that dives deeper into AI agents, covering concepts, let me know in the comments. If enough of you are interested, I will be happy to make a dedicated deep dive series. If you want to try these examples yourself, you will find the complete source code in the GitHub repository linked in the description below. I have included both the Python scripts and the Jupyter Notebook versions, so you can follow along in whichever format you prefer. For Agentic Calculator, you will find three implementations: a basic version without tool calling, the Gradio application demonstrated in this video, and a Langsmith integrated version that lets you inspect the complete execution flow of the agent. If there is one thing I would like you to take away from this video, it's this: nothing magical happened when we build the AI agent. We didn't throw away Python and start over. We simply changed where one important decision was made. In the procedural calculator, that decision lives inside our if and else statements. But in the agentic calculator, that decision is made by the language model, which then calls the appropriate Python tool. Once you see that distinction, AI agents become much less mysterious and much easier to understand and build. More importantly, now you know how to choose between these two approaches. If your application follows a clear, predictable sequence of steps, traditional programming is usually the simplest and best solution. But when your application needs to understand natural language, interpret a user's intent, or decide dynamically which capability to use, that's where an AI agent becomes a natural fit. I hope this comparison helped you understand not only how to build these applications, but more importantly, how to decide when each approach is the right fit. If you found this video helpful, please consider liking the video, subscribing to the channel, and sharing it with someone who's beginning their journey into AI agents. Thanks for watching, and I'll see you in the next video.